Good morning, everybody. Welcome to day 3. We've already learned how to solve linear equations by graphing. That's the one that takes the longest amount of time. You probably don't like it as much. We have substitution now, which many of you are getting very good at. I can see your assignments coming in. That's coming along nicely. Many of you are going to like this one the most. The algebra feels the best. This is the technique we'll use with word problems, but you still need to know these two techniques, so we will be reviewing them early next week. But linear combinations, students like it. Many books, if you look at other resources, they'll call this the elimination method, but the real name for it is called linear combinations. That's what we're doing, is we're combining lines together. To combine lines together, and you'll see us do that in just a moment. So, this is the perfect technique used for word problems, and it's also used if you're getting difficult answers, fractional answers. So you probably noticed on the substitution assignment, all the x's and y's were whole numbers, or at least they were supposed to be. On this assignment, it's very likely you'll get a fraction here or there. Okay, so let's get going. We are going to do 7 examples. This shouldn't take too long. Your homework assignment has 20 examples, I think. So anyway, keep working hard. Let's see how it works. We have a line, we have another line, and this line especially, the slope is ugly and the y-intercept is ugly. Graphing this would be a nightmare, But here's what I want you to notice. Both of these equations are in standard form, aren't they? The x's are lined up, the y's are lined up, but the important thing that you notice is that the coefficients of the two y's are opposites of each other. 2 and negative 2 are opposites of each other. So what I'm going to do is I'm going to draw a line, and I'm going to add these two equations together. The algebra is really, really nice here. When I add them together, the y terms drop out because they're opposites of each other. So I'm bringing my equal sign straight down, and what's 5 plus 7? Well, that's clearly 12, right? And what is x plus 3x? 4x. So notice with the y's dropping out, I'm going to get my x value faster than I would in substitution. So this is a really nice technique. If I just quickly divide both sides by 4, I learn that x is equal to 3 right away. So I'm going to put my parentheses there. I'm placing 3 in my x position, and now all I have to do is solve for y. I have a choice. I can plug in the 3 here, I can plug in the 3 here. I'm going to try to choose the one that's easier. To me, the top equation does look easier, so I'm now actually substituting. I'm plugging in 3 for x. I have to complete the rest of the equation. And now we're going to solve for y, which is also easy. So subtract 3. That leaves me with 2y equals 2. And now, of course, if I divide both sides by 2, I get y equaling 1. So I'm getting to point 3, 1 very quickly. If I did this problem using substitution, it wouldn't be too bad, but it's a very efficient way to solve equations. Once again, you can always check your solutions by plugging in 3 here and 1 here and making sure it works. I can also plug in 3 here and 1 here to make sure it works in the second equation too. All right, let's move along. In this example, notice that these coefficients aren't opposites of each other, they're the same. And here, these have opposite signs, but they're not the same. So, we need x coefficients or y coefficients to be opposites of each other. That's what allows the variables to drop out. So I'm going to be clever. I'm going to take the first equation, and I'm going to multiply through by 2. If I do, something good happens. When I distribute the 2 all the way through, I get 2x minus 2y, and then equals negative 8. So notice that this equation is the same as this equation. And so now I can add these two equations together. That's really nice. X plus 2x is 3x. And notice the 2y and negative 2y will drop out. And 5 plus negative 8 is negative 3. So can you see, boom, we're going to have our x coordinate in just a couple seconds. If I divide both sides by 3, I get x equals -1. Are we done with this problem? Of course not. We have to find the y value still, right? So I'm going to look at the equation that looks easier. I like the second equation a little bit more than the first equation because the first equation has a negative in front of the y. So I'm just going to go and migrate to that second equation, and I'm going to write -1 plus 2y equals 5. You see the substitution I made, right? And now if I just add 1 to both sides, I get 2y equaling 6. And a quick little divide by 2 gives me y equals 3. So now don't I know both my x value and y value? So the answer should be -1, 3. I'm not going to show testing these, but if you're unsure about your answer, plug them into both equations, make sure that they're working, and you'll feel more confident about yourself, especially if it was a test. Okay. I'll take you through a few more examples. Think about what number I can multiply the top equation by so that corresponding coefficients would be opposites of each other. There's a 1 here and there's a 1 here. The y term is negative and the y term is positive here. If there was a coefficient of 3 here, wouldn't these equations drop out, or at least the y values would drop out? So I'm going to take the top equation and I'm going to multiply through by +3. This is not the only way to do it, it's just a good way to do it. This gives me 3x plus 3y equals 3. And now a very similar thing is happening. I add these two equations together, I get 5x equals 15. What happened to the y's? They dropped out because those coefficients are opposites, right? If I divide by 5, I'm getting x equals 3. So once again, I'm half done with my problem. I know the x coordinate is 3. And between these two equations, top and bottom, which one looks easier? Oh my goodness, the top one's much easier, right? X plus y has to be equal to 1. That means 3 plus y has to equal 1. Be careful, subtract 3 from both sides and I end up getting y equals -2. So answers are spilling out very quickly. This is the most powerful technique for solving systems, but we need to see just what can happen. It might get trickier. We've got to do ones that are a little bit trickier. An example 4 is trickier because 2 doesn't go into 3 evenly. 3 doesn't go into 4 evenly. So when you have an equation like this, we're going to have to multiply both equations by a number. I'm going to be putting parentheses around both of our equations here. I'm thinking about the fact that these coefficients are -3 and +2. What number do 3 and 2 both go into? Well, the answer to that is 6, right? So can you see if I multiplied through by 2 on my top equation and 3 on my bottom equation, that the two equations will have opposite coefficients in y. So if I distribute the 2 up top, I get 8x minus 6y equals 22. If I distribute the 3 here, I get 9x plus 6y equals -39. Numbers are getting a little bit big here, but notice these two equations are perfect to add together. The y's are going to drop out, aren't they? 8x plus 9x is 17x. Oh my goodness, that makes me nervous. But -39 plus 22 is the same thing as 22 minus 39, which is -17, and now I can breathe a sigh of relief. Because now, if I divide both sides by 17, am I going to get ugly numbers or pretty numbers? Well, this is going to be pretty numbers, right? Because -17 divided by +17 is -1. So I was stressing over nothing. So this problem has to be -1 comma something. And to find the y value, it's a little bit tricky, but I need to plug in my -1 for x either in the top equation or the bottom equation. I'm going to choose the bottom equation. I'm going to erase this stuff so it's a little bit easier to see what's happening. And that equation, when I plug in -1 for x, That gives me 3 times -1 plus 2y equals -13. So be careful with your algebra here. -3 plus 2y equals -13. I'm going to add 3 to both sides. That gives me 2y equals -10. Check these with your calculator to make sure we're not making arithmetic mistakes. Divide by 2, and I'm getting y equals -5. So -1, -5. I would not want to be doing this problem by graphing. 3 more little problems and then we'll wrap it up. On this problem, if you stare at it for a second, you should say, wow, we're ready to go. Because look, the coefficients of y are already opposites of each other. So I'm not going to multiply at all. I'm going to go straight to adding the 2 lines together. 3x plus 6x is 9x. Once again, the y's have dropped out, and 3 plus 3 is 6. Okay, now staring at this equation makes me a little bit nervous because I'm dividing both sides by 9, and does this look like a whole number or does this look like a fraction? Well, 6 divided by 9 is the same thing as 2/3. We are dividing the top by 3 and we're dividing the bottom by 3 to reduce to 2/3. Students will often get concerned when they get these fractional values, but guess what? That's why we have linear combinations, is to answer these questions that are harder. We would never have a problem like this where we had to graph to find the solution, because it would just be too difficult to find that point using graphing. The worst part of this problem is I now need to take 2/3 and plug it in for x, either in the top or the bottom equation. I'm going to use the bottom equation because all the terms are positive. I think it'll be a little bit easier. But using the bottom equation, we have 6/1 times, I'm writing number 6 is 6/1 times 2/3, and then plus 2y equals 3. So be careful here. 6 times 2/3 is 12/3. 12/3. 12/3 is 4, isn't it? So that's 4 plus 2y equals 3. Okay, we're just taking our time. We're being very careful in solving for y. Subtract 4 from both sides. This gives me 2y equals -1. And I can see we're going to get a fraction again. We're dividing both sides by 2. So the y value is, you can just recopy that. -1 divided by 2 is a fraction. And it is the fraction -1/2. Without linear combinations, this problem is a nightmare. With linear combinations, this problem is actually doable. Most of your answers will not be fractions on this assignment, but at least one of them will be. All right, our last 2 problems. And look at the title, special system. Something special is going to happen on these last 2. There won't be very many special systems on your homework, but early next week, Monday and Tuesday, there will be. So you are responsible for this type of system, but you shouldn't expect this to happen on this assignment much. Okay, these coefficients of y's are the same. These coefficients of x are the same. So hopefully you can see that if I just take one of them and I multiply through by -1, that will make the coefficients be opposites like we want. So that gives me -3x plus y equals -1. And so now I'm ready to add the equations together. When I add them together, -3x and 3x give me 0. -y and y also give me 0. So can you see all the variables dropped out? Over here, -2 and -1 combined together is -3. So this is, you can see why this one's special, right? We are not getting a single point this time. This statement here is never true, right? Never true, which means these lines never cross each other. So what does it mean for lines to never cross each other? They must be parallel, right? Okay, so what we say is that this system has no solution. right? The solution to a system is where the lines cross. And do parallel lines ever cross? The answer is no. So we say no solution, and then you're going to tell Mr. Ray on your test or quiz or homework why there's no solution, and that's because we have parallel lines. Both of these need to be written down for full credit on a special system. Last problem. All right. Now, 3 and 6, they're not opposites of each other. 1 and 2, they're not opposites of each other. But hopefully from the earlier examples, you can see that I want to take the top equation and multiply both sides by -2. When I do, I get -6x minus 2y equals -8. And now we're ready to add the two lines together. What is 6x plus -6x? 0. What is 2y and -2y? 0 again. Make sure you write this down. This is the important evidence for why your answer is what it is. And what is 8 plus -8? 0 again. So this problem is similar to this problem, but here this statement is never true. Never true. So no solution with parallel lines. Is this statement never true or always true? Well, the answer is always true, which means these two lines always intersect. So how do two lines always intersect? Well, I'm not going to draw them perfectly for you, but one of the lines looks like this. And guess what? The other line looks like this. So what we did was we gave you two lines that are actually the same line. We just didn't recognize that when we initially started with this problem, but both of these are actually the same line. So we can't just tell you what the answer is because there's millions of answers. We're going to write infinite number of solutions because these lines intersect each other in an infinite number of spots. The reason that there's an infinite number of solutions is you need to tell Mr. Ray that they are the same line. Okay, so every time we have a system where the variables drop out, there's either an infinite number of solutions or there's no solution. All right, that's our last example. I wish you luck. I'm here to help you, so work hard and have a nice weekend.